Welcome everybody to the AP Chemistry series. Today we will complete part 2 of section 7.6, which is all about properties of the equilibrium constant. If you want to understand the previous video, you can follow the link in the description box, and let's start. So we covered 2 rules in the previous video. We start with the third rule, which is all about when reactions are added together, the K of the resulting overall product of K's for reactions that were summed. So what does this mean at that point? Let's have a reaction in here. The question says, how can I calculate the value of Kc for this reaction? The provided pieces of information are given here. We have the 3 reactions with their corresponding values of Kc's. I have to use these values in order to calculate the value of Kc for the reaction above. So what we can see here, I can add all of these equations together, okay? If you add them together, you will end up with the same equation that is our target. So for example, if we add equation 1, 2, 3 to each other, we can see that the product D is cancelled with reactant D in the second equation. And the same thing is repeated with a second equation for F product with reactant F. And if we add them after like canceling these species, you will add A plus B plus E plus H gives produces C plus G plus J plus I, which is the same one as is the one above. But you have to keep in mind the values of Kc's are given to us, right? How can I represent them? How can I calculate the target one in here above? This is my target. So the rule says we do not add the values of Kc's, but instead we have to say, since we added all of these equations together, then the value, it will be the multiplication of the Kc's values. So it's going to be the first equation has a corresponding value of Kc of 2, it's multiplied by the value of 4, and then it's multiplied by the value of 3. So these values are just produced from here, like the values of Kc's, and we will end up with a value of 24. Let's take another example. The question says here we have an equation that represents the target one, and we are given another 2 pieces of equations. We have equation number 1, equation number 2, with their values of Kc's. Now my question is, how can I calculate the value of Kc for this reaction? You can see if we take the 2 equations, do I manipulate them first or not in order to get this one in here? So generally you can see, for example, if we add them, like first of all, I can cancel the value of CO2 with the value of CO2 in here, and it becomes CO2. For the water in here, it's H2O, H2O, we can cancel the water thingies. So one water molecule left behind. And for oxygen, they're canceled because, they have a same magnitude and their products reactants, And okay, so at the end, I have to say the remaining things is going to be CO2 plus CH4, okay, and then CH2CO, and then water. So is this one here the same as the one here? Yeah, sure. So since we're adding the 2 equations, the multiplication process is going to take place right here. So I have to say the value of Kc for this reaction, let's say reaction 3, is equal to the value of K1 times K2. And it's going to be 6.1 times 10 to the power 8 times 1.2 times 10 to the power 14. And we will end up with this answer. Let's take another example. Look at this in here. Pause the video and read the question carefully. As we can see, we are given 2 equations, all right? And the question is asking me, how can I find the relationship between the 2 guys in here? Now, if I want to represent the value of, as we can see, like all of the choices starts with K2. So if I want to change K1 to be K2, what should I do? First of all, you have to look at the equation. You can notice that the equation both of them have CO3, CO3, almost the same species, but my target is how can I change the value of K1 to be K2? All right. So first of all, you can see that the first step here is a flipping up the equation because these are inverse to each other. So the first thing I have to say, K2 is equal to, I need to change the value of K1 to be reversed, to be the same as this one in here. So if you revert it, then you have to take the reciprocal of the value of K1. Okay, but we didn't finish. If we just take reciprocal, it's going to be SO3, and then we have half O2 plus SO2. But if you look at the value of K2, the coefficients of the species is 2 for SO3 and SO2, and 1 for oxygen, which means I have to multiply the whole equation by 2. And we said that the multiplication process represents the coefficient. Okay, the coefficient represents the power. So I have to raise this one here to the power 2. So which of these answers? We can see that the answer is C. And now, lastly but not least, the rule says if you're dealing with K, whether it's KC or KP, all right, the expression and the same procedure, the same manipulating things will be applied on the value of a QC, the values of a QP.